Hello, for this lesson, today we will be working with high school geometry students. The techniques for this lesson are applying formulas for the area of regular polygons in order to solve problems using the appropriate units of measure, determine the area of composite two-dimensional figures comprised of triangles, parallelograms, etc., identifying shapes of two-dimensional cross-sections of prisms, pyramids, cylinders, cones, and spheres, and identify three-dimensional objects generated by rotations of two-dimensional shapes. Some of the prior knowledge of that students will need for this are just some of the basic regular polygon area formulas for like a parallelogram, which is base times height, or for a triangle, which is 1/2 base times height. Those will be helpful in going through this lesson, through at least some of the demonstrations of this lesson. And then the book that I'll be reading from is called the Big Ideas Math Geometry by Larson and Boswell, and went to chapter 11, which says, starts off with, a composite figure is a figure that consists of triangles, squares, and other two-dimensional figures. To find the area of a composite figure, separate it into figures with the areas that you know how to find, then find the sum of the two areas. It goes on to say, give some more definitions of a regular polygon. The center of a regular polygon is the center of its circumscribed circle. The distance from the center to any side of a regular polygon is called the apothem of a regular polygon. And then after giving those little quick definition, I will then hand out some scratch paper, just regular scratch paper that students can draw on, and all of that. I will also hand out little math manipulatives, little shapes and geometric figures that they can trace and do all of that, which is what we will be doing. And for this first part, I will ask them to trace one of these little triangles. And after doing this, they'll trace it and come out with this shape. Excellent. And label it according to the size with 3 meters, 4 meters, and 5 meters, as so. And then from there, I will ask them to find the area of this triangle, which they will then hopefully recall and produce the formula equals the area equals 1/2 the base times the height, which in this case would be 1/2 times 3 times 4, which would be 1/2 times 12, which is 6 meters squared. Since we are dealing with area, this is going to be meters squared. And then after that, I will have them take some other geometric shapes, another triangle, this is an equilateral triangle, and then this little cube, this is the only square thing that I had in my bag of shapes, and so I will have them trace these. Not make them 3D, but just trace them onto the paper, just the regular shapes of the triangle and the square, and they'll come out with this shape, like so, to create some sort of little house. They will make their little house, and I will tell them to label their the sides 4 meters. The sides of the house is 4 meters, the base of the house is 4 meters, since it is a square, those sides are equal, and then the roof of the house is also, the legs of it will be 4 meters, while the roof height will be 3 meters, and I will then proceed to ask them to find the area, the total area of that composite figure. which would be, let's see here, what would this be? This would be 1/2. Anyways, they will find the area of that triangle of that house, and then from that I will proceed to give them a quick definition of what a three-dimensional net is. And from that, I got that definition from this book as well, and it says here that a net for a three-dimensional figure is a two-dimensional pattern that can be folded to form a three-dimensional figure. And from then, I will pass out three-dimensional nets that I found on the internet, nothing crazy, and I'll ask them to cut out along these black lines, along the solid lines, until they end up with something like this. Looks like a little star in this little geometric net. And from then, I will then either demonstrate if they need to, or if they can do it on their own, ask them to fold along these black lines, just along this square, in order to, just like so, until they end up with a little pyramid. And they fold and fold until their pyramid comes out looking like so. Once their pyramid ends up like this, I can ask them just simple questions as to how many faces they have, which on this would be 4, how many bases, which would just be 1, the number of vertices, which would be 5, how many edges, just simple questions in order to get some feedback and see if students did gain anything from this. And then as an extra credit problem project, or somewhat something a little more challenging for students, you could give them one of these bigger nets. This is for a dodecahedron, and this is it's a platonic solid that will, when folded, will give you a 10-faced, almost a sphere, but technically it's not, because it's not completely round and all that good jazz. So that would be our lesson.